Good morning and good afternoon and good evening to everyone watching this video. My name is Helen Grace Gonzalez and I'll be presenting to you a doctorate as presentation for our subject Industrial Design and Quality Assurance. The title of my research is Designing Biomimetic Robots, Iterative Development of an Integrated Technology Design Curriculum by Wendell et al. Under the Education Tech Research Development Journal. Okay. So the contents of my research would be introduction, proceeded with a design-based research approach, discussion, then educational intervention on evolving design, and next would be analysis and results. So, what is designing biomimetic robots, or what is this project all about? In middle schools, especially in the US, learning is actually segregated by discipline. So science is taught in one class, and then engineering or computing are taught in another, if at all, no? Yet today, discovery and innovation are interdisciplinary, and students need to use skills and practices from multiple subject areas to solve problems. The Designing Biomimetic Robots project actually created authentic interdisciplinary learning experiences for students that are actually more similar to what is currently happening in science and engineering fields or in the real world scenario. Okay. The project actually developed and study an education program that integrates science, engineering, and computing by engaging students in biomimicry design challenges. So in these challenges, students first study the natural world to learn how animals and plants accomplish different tasks. So, which means biology. Then they will engineer a robot that is inspired by what they learned. Okay. These design challenges will support students to develop computational thinking, scientific reasoning, and engineering design practices, while allowing them to practice interdisciplinary problem-solving skills. So in addition, the project actually demonstrate how teachers can foster interdisciplinary learning and can broaden participation in science, engineering, and computing among middle school students. Okay. So actually the setting of this research is in the US, and it involves us work with 13 teachers, middle school teachers, and 400 students in different schools in Massachusetts, Maryland, and Maine. So this is a 4-week modular and flexible curriculum that integrates biology, bio-inspired engineering design, robotics, and computer programming content and practices into middle school, science, engineering, and STEM classrooms. So the goal of this research is for participating students to develop knowledge, practices, and skills consistent with engineering and science standards and computational thinking principles, and also demonstrate an understanding that computing enhances STEM practices and knowledge development. Okay, so the project has actually engaged science, engineering, and technology teachers as well in the work. So based on the feedback, um, the researchers has actually have made iterative curriculum revisions to better support teachers in all 3 disciplines: science, um, engineering, and computing. The researchers also found that curricular revisions and professional development have positioned teachers to to deliver unfamiliar content effectively and with confidence. Hence, there will be future researchers that will be able to examine this type of impact as well. So additionally, the data from the classroom discussions, the student-created robots or the outputs, design documentation, and student interviews indicate student learning in all three of the integrated disciplines. Okay. So if you see this actually come from the brochure, and if you see the figures, these are actually some of the outputs from the students. Okay. So this figure is actually the student animal analysis created by the students. And this figure, last one, is actually the storyboard and final robot inspired by a pangolin. Okay. So these are actually outputs of the students. The researchers actually believe that the design-based research project actually contribute a lot to the understanding of how to create effective interdisciplinary learning environments. So the researchers hope that the educational research theory about the interdisciplinary education and integration of robotic design tasks can be implemented in the classrooms. Okay, so what is design-based research approach? If the researchers mention that it is really effective, especially in interdisciplinary programs, what is DBR? So, uh, a design-based research is actually in an educational setting, it's actually a design-based research that is a research approach that engages in iterative designs to develop knowledge that improves educational practices. So the design-based research is actually a methodological approach that aligns with research methods from the fields of engineering or applied physics, where the products are designed for specific purposes. So, example, if the researchers were able to identify a problem that needs to be addressed, then they will design a potential solution to that kind of problem in a form of instructional materials or tools. And then that theory or and previous research suggests that can actually address the problem. And then the researchers test this instructional tool or materials in our real world setting, okay, to see if the tools positively impact student learning. Okay, and then as the testing proceeds, after the testing, researchers will evaluate the instructional materials with emerging evidence of their effectiveness, so if it's effective or not. And then finally, researchers will have to reflect on the outcomes of that experiment, identifying the features of the instructional tool that were successful at addressing the initial learning problem. So that is what design based research is. It's most likely in an educational setting, and it can be used especially in curriculum designing. So in this figure, in this slide, you can see it's still a loop. A design-based research will not end with the reflection. If there are things that needs to be changed with regards to the tools implementation process, then it can go back to the design or the revision of the design. Just like this one, this is actually the figure 3 from the research that they have actually created. These are the process that the students undergone. So aligning science practices, engineering design, and computational thinking process. So first, the students actually learn about the design tasks, and then next, they were able to study animal function, animal structure and function, and then they were able to create representations of animal structures and function. First, they study and then they create, and then they design a robot that mimics the way an animal digs. So example, if they need in the search and rescue, then they want to create an animal that can actually dig. And then next, they will proceed with building the and program and test the robot. And lastly, they are going to iterate and report, or most like they are going to reflect and then critique on the implementation of that certain solution. So actually, the curriculum provides resources to support investigations in biology. okay, and engineering. Students were able to build robots using craft materials, and the Hummingbird Classroom Robotics Kit is actually provided, and they were able to program robots using Scratch and make code. So this is the instructional approach to the student design task, and the ways in which the researchers were able to support students in practicing engineering design, biological investigations, and computational thinking. And then this is actually a 3-year project. So if you see here in the year one, this is actually the educational intervention, or the evolving of the design. So this is the first initial design conjecture of the project. If you see, there's the embodiment, comprised of the tools, the materials that the students were able to learn, the programming, computational thinking, biomimicry, engineering design, and robotics. Uh, Take note that there is all the discipline are actually equal. There's not one discipline that actually dominates another. Okay. So task structures, designing and building, iterative testing, programming, conceptual model building. All of these are the students were able to learn this one also. And students have been able to do pair programming, have done collaboration, peer critic, and discursive practices as well. Okay. So after that, as the mediating processes is that students were able to do a peer-to-peer talk, and then with the use of the tools, the students were able to engage, and then students have been able to provide or present their own robots and design sketches. So these are actually their outcomes or outputs of the students. While the outcomes are the knowledge, practices, and the student's self-efficacy. So, as the scope, sequence, and curricular resources evolved and the discipline alignment sharpened, we saw that there's a change in the students' ability to engage in integrating disciplinary work. So this is actually the conclusion of the researchers. During the year one, the students needed help from their teachers. So these are just some of their um, uh, these are some of their reflections during the research. So during year one, students needed help from their teacher to prioritize and execute their designs and building efforts. It was the teacher who helped the South Scout Roach group prioritize certain actions for the robot and then encourage them to focus on mechanisms for compressing the robot's legs and body. But in contrast, in year three, the deep animal analysis work completed by the students guided the robot design process and final product, enabling students to move from animal investigations to their initial robot design more independently, and ensuring that their design iterations maintain a focus on mimicking animal structures and functions. So it is noted that in year three, there's actually a changes or revisions in their curriculum, and this is what the purpose of using the DBR in this research. So these are some of the summary of how student activities aligned with curriculum learning goals from year 1 to year 3. And it is mentioned by the researchers that the study showed that the explicit and targeted curricular supports prioritizing specific science, computational thinking, and engineering practices chosen for their natural synergies among the disciplines, specifying how students should engage with the practices in the context of design tasks were necessary to support integrated learning. So the researchers believe that the implications of the findings of their research have actually provided relevance for the design of integrated curriculum. So, researchers also mentioned that future research could address how teachers take up and enact challenging curriculum and or curricula on how student learning is supported by careful design of resources and representation across disciplines. So that's all, and I hope you learned something from my presentation. Thank you.